Good morning, it's me, Mr. Trewen. We are back from a little winter vacation and ready to finish this grading period off, finish this chapter off. So today we'll be looking at one of the last sections in our textbook for this chapter, which is triangle inequalities. And what we're going to be focused on today is we're going to be comparing sides of a triangle to the angles in a triangle and seeing how those are related. Now we call this inequalities because we won't be using equal signs for any of the comparisons. We'll be using greater than and less than symbols. So the first theorem that we're going to look at today is how the sides of a triangle are related to the angles. Now there are two theorems, and I only wrote one, and I'll explain that in a moment. The first one we're going to look at says the largest side of a triangle is opposite the largest angle in a triangle. So I want to go over this again, as I've said many times before. Opposite in geometry is not like positive and negative. It's not up and down versus left and right. When we talk about opposite in geometry, we're talking about a position. So for example, the camera is opposite of me as it's across from me. So when I say something's opposite of it, I'm talking about directly across from it. So when I look at this theorem, it says the largest side of a triangle is opposite the largest angle in a triangle. So let's look at our example. I have three angles, 20, 30, and 130. Now I know it seems pretty obvious from looking at the picture, but if we were to not look at the picture and focus only on the numbers, if I said what is the largest side of the triangle, we would need to look at it and say, all right, well, what's the largest angle? Well, that's 130. So 130 is opposite, again, pointing right out, is opposite of side B, which means that B is the largest side of the triangle. What would be the next side? Well, if I look at the list, I have 130, and then the next largest angle is 30. So 30 is opposite of A, which means that angle B is greater than angle A. And then the smallest angle in the triangle is the 20, which means that the smallest side in the triangle is side C. So the reason we call inequalities is because I don't know the exact lengths of these at all. But all I know is that side B is greater than side A and greater than side C. I just know that that's the order. I can do that the other way. I can say, well, I know that C is smaller than A, is smaller than B, or like if we use the correct terminology, C is less than A is less than B. All right, so that is how we can organize the sides of a triangle based on angles. Well, there's a converse to this theorem that says that the largest or the longest side of a triangle is opposite the largest angle. So if I look at these, I can also order the angles. I can always tell you which angle is the largest in the triangle based on the sides. So if you look at this one, I don't know any of the angles in the triangle at all. But I do know that there's a side that has a length of 10, 12, and 14. And that tells me that angle B, up here at the top, angle B is opposite the longest side. So that means that angle B, whatever it is greater than the other ones. So when I go to the next one, I can see this, 12 is the next greatest, next longest side. So therefore C is the next in the order of which is the largest angle and so forth. And then the last one, the smallest one, would have to be angle A because it's opposite the smallest or the shortest side, however you want to say that. And again, I could say this the other way. It all depends on what I'm asked. I could say that angle A is less than angle C is less than angle B. And we call these inequalities because we're not using the equal sign. So again, the rules are basically that the largest side is opposite the largest angle, and the largest angle is opposite the longest side. So either one of those we give in this situation. If they give us the angles, we know the sides. If they give us the sides, we know the angles. All right, now the next one we're going to look at is what determines, or how we determine if something can even make a triangle. Because we do have to have some specific lengths to even make a triangle, because if we don't have lengths long enough, we wouldn't be able to connect the sides of a triangle. So let's look at the theorem. It says, two sides of a triangle must have a sum that's greater than the third. So in simplest terms, what I'm telling you is this. Two sides always have to add up to more than the third. If they do not add up to more than the third, the triangle is, we cannot close the triangle. We cannot make the sides connect because they're not long enough. So when I look at these three sides, for example, in my example 3 here, I say, can the following lengths make a triangle or form a triangle? Well, 8, 10, and 12, all I need to do is put them in order from least to greatest and make sure that the two sides add up to more than the third. So for example, 8 plus 10, and then 12, or 8, 10, and 12 are in order, so 8 plus 10 is 18. 18 is greater than 12. We have a triangle. That's good to go. No problems there, because they're in order from least to greatest. I could do that on and on. I could say that 10 and 12, 10 plus 12 is 22, and that's greater than 8. But I already know that's going to work because if I put them in order, all I need to do is this one time and I'll get the answer. If I forget to put them in order, I might make a mistake. For example, like on this one here, these are not in order. So you might just jump in and say, oh yeah, 7 plus 12 is 19, that's greater than 4, triangle. Well, that's wrong because when I add up, for example, the 7 and a 4, that only makes 11, and that's not greater than 12. So it doesn't work. So I gotta make sure that I always put my numbers in order before I start making a comparison. 4 plus 7 is 11, which is less than 12. This is not a triangle. Can't do it. It's because you have two sides that are not long enough to connect based on the third side. So what's happening is I got these two. I just want to draw this out quickly. Let's say I got this side that's this long, and then I've got one that's like this, and I've got one that's like this, and they just aren't long enough to close because these two are not greater than that one. They won't connect. It's impossible. They just don't add up to enough. If you think of it as a picture, let's say this is the 7, this is the 4, and this is the 12. They're just never going to be, because 4 and 7 is 11, they're not long enough to close the gap, and therefore it's not going to make a triangle. I can have an isosceles triangle, but this one I've drawn out for you might not work, because 9 and 9 is 18. 18 is equal to 18. That means that I've basically drawn a triangle that has two sides like this. Here's the one that's 18, here's the one that's 9, here's the one that's 9, and they just simply don't connect because they're the exact same length. They just have to be greater than. So the rule is, again, that two sides have to be greater than the third, and just make sure you put them in order and you'll never have any issues. All right, the last and most complicated part of this is in our book today, or in our assignment, we're going to be asked to determine a range of values that make a triangle. So, for example, I told you that two sides have to be greater than the third. Well, if I gave you sides 12 and 18, there are quite a few numbers that would actually meet that rule and make a triangle. If I have a side that's 12 and a side that's 18, it's not like there's only one number. There's a bunch of numbers. And there's a range of values, and the way we find them is we do two simple calculations, and we can find all the values that make a triangle. And the first one is, how do I find the biggest number that would make a triangle? And I do that by finding 12 plus 18. So if I add them together, I get 30. Now, 12 and 18 have to be greater than 30. They have to be greater than the other number. So I know that the maximum number that they could ever add up to is 30. I need to know the smallest number, and I'm going to do that. Instead of adding them together, I'm going to subtract them, and I'm going to say 6. Now, our values are between 6 and 30, but specifically, I'm going to put the value x, I'm going to use the variable x to represent all the different choices. And what I know is that I have to be smaller than the number 30, but I also have to be greater than the number 6. And here's why. Let's throw a test in there. If I said 6, all right, 6 plus 12 is 18, and 18 is not greater than 18, so 6 won't do it. But if I said the next number up from 6, 7, 7 plus 12 is 19, and 19 is greater than 18, therefore it works. So I know that the number is somewhere bigger than 6, but less than 30. Because remember, I can't pick 30, because what's 12 plus 18? 30. And 30 is not greater than 30. So any number between 6 and 30 makes a triangle. Anything that's outside of that range does not make a triangle. So 6 will not do it, 30 will not do it, but any number bigger than 6 and smaller than 30 is our set. So whenever you get these two numbers, just simply add them together and subtract them, and this is your range of values. And it should be written in this format, where x shows, x marks the variable, and we're somewhere between here. Make sure that you use the greater than or the less than symbols. Do not put this symbol. If you put that symbol, that's incorrect, because remember, we can't be the number 6, we have to be one number bigger. Just anything bigger. 6.01 would be bigger, and that would actually make a triangle. Very bizarre looking triangle, but a triangle. So I hope this helps, and I hope that answers all your questions. Have a good day.